Okay, this video tutorial looks at the mathematical strand of matrices, and more specifically, we're going to focus our understanding on using matrices to solve equations and looking at what an inverse matrix is. So in previous units, we've looked at solving simultaneous equations, and when we were looking at them, it's probably come in the form something similar to this. Now, these simultaneous equations, can be written as a matrix. All right, where we have our matrix. So if we're going to use the same equations we've got our 2, 3, 5, and 4 written as a 2 by 2 matrix. We've got our x and our y written as a 2 by 1 matrix here, and we've got our answer as a 2 by 1 matrix in the 4 to 14. Now, obviously, if we're going to multiply out this here, all right, we would end up with 2x, 3y, 5x, and 4y. All right, and we want to add those. And obviously that's going to give us 4 and 17, which would then go back to what we originally had. All right, we can check these by substituting some solutions of 5 and 2 into our matrices to then get our answer, and that is demonstrated here. All right, it's important to notice that these matrix equations have a form of AX equals B, where A is one matrix, X is our XY matrix, and B is our final matrix. All right, but then once we understand that, how can we use that information to be able to solve for our X matrix, okay, or our XY matrix in this particular case? Well, let's have a look at it. So suppose there exists a matrix C, all right, such that if we multiply C by our A matrix, it gives us our identity matrix. Now, remember that our identity matrix in a 2 by 2 is 1, 0, 0, 1. All right, so we're looking at our C matrix multiplied by our A matrix, which should then give us 1, 0, 0, 1. That's important to understand. All right, if we multiply, as you can see here, if we multiply our C by our AX in our AX equals B equation, all right, then we're going to end up with IX. Now remember, IX just leaves X, and that's going to be equal to CB. All right, so we've ended up with finding X because we've multiplied our B matrix by our C matrix. It's important to know that if we're going to find our C matrix, it's actually the inverse of our A matrix. So C is going to be the inverse of A. So essentially, if we combine this, we end up with X equaling the inverse of A times by B. All right. So we originally started with AX equals B, so therefore X is now going to equal the inverse of A multiplied by B. All right, just something to consider is that the multiplication of the inverse of A, so if you multiply the inverse of A by A, you end up with your identity matrix. Okay, that's really important to understand, okay, because if we go back up to the top, we've got our CA equals I, and we know then, we've just worked out before that C is the same as A to the negative 1, or the inverse of A. Therefore, the inverse of A multiplied by A gives us I, which is basically repeating this down here. Now, essentially, what is an inverse matrix? All right, we just talked about on the previous slide the inverse of A. All right, and there's a blue box down the bottom, which is really, really important. All right, so our general formula for the inverse of a matrix. So in this example, if we've got a matrix A, which is A, B, C, D, okay, and these values will be represented by numerals or variables, but in this particular case, the generic formula, matrix A, A, B, C, D, so it's a 2 by 2, then the inverse of A is going to be 1 over the product of AD minus the product of BC, and you'll notice very important here, you'll notice that D and A have swapped spots, and that B and C have now become negatives. All right, so B and C stayed in the same spot, but they're now the negative of what they were originally. It's really important to make those connections, that D and A swap spots, and B and C become the negatives of what they were originally. Okay, so using those formulas and those generic formulas that we've come up with, here's a practice question I'd like you to have a go at. I want you to find the inverse of A first, and then I would like you to be able to solve the problem. Okay, solve the simultaneous equation using matrices. Please feel free to pause the video and see how you went. All right, so let's have a look at some of your answers. Now, we've got the generic formula over here, where if A matrix is A, B, C, D, then the inverse of matrix is the product of A, D, take away the product of B, C, so 1 over, A, D, take B, C. We've got our A and our D, which have flipped or switched, and our C and our B have become negative. Okay, so we can see here that this matrix is our A. All right, we've got our X and we've got our B. So remember the formula of AX equals B. Therefore, X is going to be the inverse of A multiplied by B. All right, which is essentially what we've got down here. We've got the product of A and D here minus the product of B and C here. Okay, you'll notice that A and D have swapped spots. All right, so we've now got 4 and 2 in the opposite spots, and we've also got a negative of 3 and a negative of 5. Now, essentially, if we multiply all that out, we're just going to end up with our answer down here, okay, where we have the answer of our X value being 5 and minus 2, so therefore our X value is 5 and our Y value is minus 2. So that was our X matrix.